Hello, I'm Param Singh. Now we are going to look at compound data structures to model information that naturally comprises of two or more individual pieces of data. So the first one for us is tuple, which is used to model the compound data of fixed size. So what do I mean by fixed size? Meaning if the number of components are not expected to change as the program executes. For example, a point on a 2D plane naturally comprises of two pieces of data. The first one is a number which represents the units along the x-axis, and the second one is a number that represents units along the y-axis. So this representation of a point on a 2D plane will always remain the same in terms of the number of components. And this is a good fit for representing with tuple. So how do we construct a tuple? So we put the component values inside curly braces, and the values are separated by comma. Let's look at few more examples beyond this point on a 2D plane. By the way, the type of the point on a 2D plane will be represented by this. So curly braces, number, comma, number. The next example is 3 integers, and that can represent an RGB triple. So those are your 3 colors, red, green, and blue. For example, 255, 255, and 0. The next example is a 2-component tuple where first is an atom and second is a string. And this could represent a response from an API. For example, OK and some data when the response is successful, or error and some failure description of that error. In addition to looking at how to construct the tuples or any compound data structure, we also need to know how to select the individual components. So that's where the selector syntax comes in. And this is once again where pattern matching in Elixir becomes quite handy and useful to select the individual components from a tuple. The first example here is x comma y equals 1 comma 2. So here's a match because the right hand side is a value of 2-component tuple. Left hand side is also 2-component tuple. So x will be bound to 1 and y will be bound to 2. In the next example, the right hand side is the same, but the left hand side is 1 comma y. So this will match any 2-component tuple where the first value is equal to 1. So here the first value is indeed equal to 1. So y will be bound to 2. In the third example, the first component is represented by underscore on left hand side. And this means it will match any 2-component tuple, and the first value could be of any type. So this could be a number, a string, an atom, or any other compound data. So this is kind of a match all. And then in this case, y will be bound to 2. So this is commonly used in situations where we only need to use some components from a tuple and discard the rest. So underscore will be used to discard the components that we don't need. The fourth example says that we will match any 2-component tuple as long as the two values are exactly same, because both variables are having the same name x. And this particular case will result in a match error because right hand side is a 2-component tuple, but the two values are different. And final example will also result in a match error because of the number of components differences. So the left hand side is saying we will match a 3-component tuple. On the right hand side, we only have a 2-component tuple. So this will result in match error. So let's look at these examples in IEX now to get some more practice and understand these concepts. So let's see how we can create tuples in IEX and also extract their components using pattern matching. So this is a simple example of a 2-component tuple. The value is 1, 2. You can have values of different type. For example, we have a atom, string, and an integer. So when we want to extract the components, we'll use pattern matching. For example, if I use this pattern match, Elixir will look at the right hand side and say it is a 2-component tuple. The left hand side is also a 2-component tuple. So in this case, x will be bound to the value 1 and y will be bound to value 2. Now, if you want to do an exact match of value, for example, we are proposing that first component on the right hand side must be 1, and then we'll bind y to whatever the second component value is. So if I write a pattern match like this, so this will match and bind the y variable to OK. On the other hand, if this value doesn't match, then it will produce a match error. If we want to only get few of the all available components within the tuple, we can use this discard operator, if you will. So here we are saying match a 2-component tuple. We don't care what the first value is going to be. Bind the variable y to the second value. So in this case, y will be bound to the atom. Okay. If we want to make sure that the values are same for the components, we can use the same variable name on the left hand side, and this will result in a match because both values on the right hand side are same. On the other hand, if the right hand side values are different, then it will produce a match error. If we have the number of components that are different, for example, here we are saying the left hand side should be is a 3-component tuple, and on the right hand side we just have 2 components, result in a match error as well. So that's how we extract components, discard components, create tuples, and make use of pattern matching.